Hello everyone, welcome back to Excel Education Center. It's me Nabeel. So today I'm going to discuss some of the important concepts and the important questions of the chapter light. So this chapter I'm actually dividing this chapter into two parts. So today we'll be discussing mainly on the part of this chapter which is called reflection. Okay, so people do understand one thing. See, this chapter will be having you will be having a mark around 10 plus marks, around 10 marks you can expect. Okay, so understand one thing, this chapter is one of the high priority chapters in physics. Okay, so without any lag we can go to the questions. Okay, so people, let's go for the first question. So first question, in torches, searchlights and headlights of vehicles, the bulb is placed where? So it's an MCQ question, so we have to go for finding where the bulb is placed. So since this chapter is based, like this part is based on reflection, you can understand one thing. See, here we are actually discussing either on concave or convex. Okay, so you will be having questions based on the applications of concave and convex mirrors. Okay, so do understand one thing, in torches, searchlights and headlights of vehicles, the bulb which is placed should be at the focus. And why focus? Okay, so it should be at the focus or it should be like very near to the focus. And why it is very near to the focus, that we have to check. Before that, what kind of mirror has to be used? See, here what we are using here is like concave mirror. It is a concave mirror. And why not convex? See, convex lenses or convex mirrors are mainly used in the places where, like, if you want to get a wide view of a particular image or something. Like usually we are using this convex mirrors in the rear view mirrors and side view mirrors and all. Okay, so let's remove the convex mirror and then we can focus on the concave mirrors. Okay, so let's see what is happening in a concave mirror. You may have studied, see, this is a concave mirror. I'm just drawing the principal axis. Okay, so let it be like here is the focus and let it be this is the C here. Listen, I'm going to keep an object here. I'm going to keep an object here. Let it be. Okay. Okay. So you know what? This beam will be passing like this. One beam which is like parallel to the principal axis will be passing through focus. And you have studied another rule. If there is a beam of light which is passing through focus, if a beam of light is passing through focus, what happens to the reflected ray? It will be reflecting back parallel to the principal axis. Hope you remember that rule. Okay, so what happens is, like, here we'll be keeping a concave mirror inside the torches. We'll be keeping a concave mirror inside the torches. Okay, understood. Okay, and then what we'll do is, like, we'll keep the bulb which is very close to the focus. We'll keep the bulb which is very close to the focus because this is a kind of concave mirror. Okay, so what happens here is, like, the bulb which will be emitting the light will be sending lights to the different parts of the concave mirror. And what happens later? See, what happens later? After reflecting, they will be going parallel to the principal axis, which will give you a strong beam. Okay, understood? So this is the concept of what? Like keeping the bulbs in the torches at the focus or very near to the focus. So what are the options here? Between the pole and the focus of the reflector? No. And then very near to the focus of the reflector, between the focus and no. So of the total, I think this, like, it is like what is the answer? It is B itself. Okay, it is very near to the focus. If you are having options like at the focus also, you can go for that. Okay, so this is the first question. Now let's go for the second question. Listen, an object is placed in front of a convex mirror. Its image is formed. See, here earlier we discussed about a concave mirror. Now we are discussing about a convex mirror. Okay, so let it be a convex mirror is there. Okay, and then it is placed in front of a convex mirror. Okay, fine. Like, see, when it comes to the convex mirror, there are only two image formation which is going to happen. One, the image is kept at infinity, and one image which is, sorry, not image, one object which is kept at infinity, and then one object which is kept between infinity and the pole. Okay, so here I'm keeping an object here, somewhere here, let it be not at infinity. Okay, so then what is actually happening? See, the image formed will be what? understand one thing, whenever the object is kept at infinity or between infinity and pole, here the image always will be formed in the what? In the other side. It will be forming in behind the mirror. It will be forming behind the mirror. So I'll maybe like I'll write, okay, so let it be, this is the what to say, here the focus will be this side, okay, and then the what to say, C is also this side, okay. Then let's see, for example, like what happens here, see, in a convex mirror, the incident rays which is parallel to the principal axis will be diverging, so it won't be making what, image here. And then see, I'll be extending the line back, and then what happens here, I'm drawing another beam of light, it also bounces back, okay, it also like go, which makes an angle of incidence which is equal to angle of reflection, and then this comes here, and here the image will be formed. Always a convex mirror will be forming virtual, erect and diminished, not diminished, like small images, okay. So here always a convex mirror will be forming what, virtual, also what, erect and small images, okay. It won't be forming any real images. But a concave mirror, it will be forming both what, real and also virtual images. Understood? So here what is the option? At a distance equal to the object distance, no, it is not in front of the mirror, not in front of the mirror, and then twice the distance, it is not, and then half the distance of the object not in front, everything is like the image will be formed behind the mirror, okay. So it will be formed behind the mirror, okay or not? So this is the option D is the right answer, okay. Now let's go for the next question. So listen, so here the radius of curvature of a converging mirror is 30 centimeter. So that means R is equal to 30 centimeter. And listen one thing, see here it is set as converging mirror. What is it? Converging mirror. What does a converging mirror means? Converging means like the beams which is incident to this in front of this mirror will be what? Converging after their reflection. So converging mirror are basically what? Converging mirror are concave, okay, and diverging mirror are what? Diverging mirrors are convex, okay. So converging mirror are concave and diverging mirrors are what? Convex. Please do keep this in mind, okay. Maybe in the numerical questions you can see like it will be either written as converging or written as diverging, so it won't be specifically given as concave or convex. So please do understand this thing, okay. Now listen, the radius of curvature of a converging mirror is 30. At what distance from the mirror should an object be placed so as to obtain a virtual image? Understands one thing, see, I need to get a virtual image. In a converging mirror, that means in a concave mirror, there is only one situation where you are getting what? A virtual image, which is this. You have you may remember what are the 6 conditions where like we are going to keep the object at infinity, beyond C, at C, between C and F, and at F. These all 5 conditions where like the object is kept, we will be getting a real and inverted image. But when it comes to the last one, which is between F and P, will be giving you what? Virtual image. Will be giving you a virtual image. So here R is equal to 30 centimeter. Okay, fine. Now let me draw simply. This is a 1 mark question. We don't have to go for too much about it, but still let me explain the concept along with that. Okay, so we know R is equal to 30. So R is what? Radius of curvature 30 centimeter. And then obviously what will be F? Focal length will be half of it. It will be 15 centimeter. It will be 15 centimeter. Fine. Okay. Now listen. I should be keeping the object here somewhere between 15 and this is what the pole. This will be what to say C, this will be F and this will be pole. Only if I keep the object between F and P, I will be getting what? A virtual image. Okay, so what should be keeping? At infinity? No, at infinity you will be getting a very small image at focus. Okay, at 30 centimeter? No, if I'm keeping at 30 means here at C. At C will be giving you an image which is at C itself. It is a same image. Okay, next, between 15 centimeter and 30 centimeter. No, here the option is the last one, between 0 centimeter and the 15 centimeter. Hope you have understood that. I should be keeping here, this is 0. The distance, always the distance will be taken from the mirrors. Always the distance will be taken from the mirrors. Okay, so this is 0 and this is 15 centimeter. Understood? So here only I'll be getting a virtual image. Okay, so now let's go for the next question. So now we'll go for an assertion reason question. Okay, now a ray incident along normal to the mirror retraces its path. And what is the reason? In reflection, angle of incidence is always equal to angle of reflection. So first of all, let's go for what is the assertion. Listen, it is like what? Here there is a mirror. Okay, I'm here like drawing a plane mirror. Okay, and then what happens here? An incident ray is coming along the normal. Okay, so let me draw a normal here. Normal will be always perpendicular to the surface. It will be always perpendicular to the surface. Fine. Now what is this like, and what is the direction of this incident ray? So it is coming along the normal. It is coming along the normal. So this is incident ray. Okay or not? So listen one thing. See, if a beam of light is just coming through through the normal, see, it won't be making any angle of incidence. It won't be making any angle of incidence. We know that there is a law of reflection, which is the what is like law of reflection says. It is like angle of incidence is always equal to angle of reflection. And what is angle of incidence? Angle of incidence is the angle which is made between the incident ray and the normal. See people, see the incident ray is here, the normal is also here. It is not making any angle between what? Incident ray and the normal. So the angle of incidence is equal to 0 degree. Understood? Okay, and what happens to this like beam which is coming through the normal? See, after reflection, what happens, see, it will be bouncing back through the same path. It will be bouncing back to the same path. So it retraces its path. So assertion is right. Assertion is right. So what should be the angle of reflection, people? What should be the angle of reflection? So it should be, if the angle of incidence is 0, then angle of reflection should be also equal to 0. Why is that? We know the second law. Okay, let's go for the reason. In reflection, angle of incidence is always equal to angle of reflection, and that is the law of reflection. Basically, there is one of the law of reflection. There is one more law. What is that law? That is what? Incident ray, reflected ray, and the normal lies in the same plane. Okay, so here listen, see, first one is right, second one, reason is also right. So that means what? Assertion is right, and for the assertion, see, R gives you the right explanation, isn't it? So assertion is true, and then reason is also true, so it gives you the right explanation also. So which one will be right here? See, option A will be right. Okay, so here, hope you have understood here. Understood? Okay, now let's go for the next assertion reason question. Next, listen. See, large concave mirrors are used to concentrate sunlight to produce heat in solar cookers. So that is the assertion. Okay, and what is the reason? Concave mirrors converges the light rays falling onto the point. I'll come to the theory of this chapter. Okay, this point. Listen, there is like, this is concave mirror, right or not? So this is concave mirror. Okay, and then listen. See, these large concave mirrors are actually used to concentrate the sunlight actually. See what happens, let it be like, I'm just drawing the principal axis. Let it be, this is the principal axis. Okay, I'm keeping it here. Okay, now listen. There will be sunlight always travels in straight lines. Like a light always travels in a straight line. Okay, so let it be like, there is like a beam of like sunlight will be coming. Okay, I'm keeping a concave mirror, very large concave mirror, okay, opposite to it. So what happens? The beam of light which is coming will be always parallel to the principal axis. They will be coming parallel to the principal axis. Okay, there will be beam of light which is coming parallel to the principal axis. The incident rays are here. Okay, and you know what? After reflection, we know one thing. What is it? All the beams which is incident, which is actually parallel to the principal axis, will be reflecting back through the focus. So what happens here? See, all those beams will be, I'll like mark it with another color. Okay, listen, this will be reflecting back to this point. Okay, let it be this is the focus. So all the beams will be like all those beams will be what reflecting back to this point. Understood or not? Okay, so what happens here? See, if let it be like usually in solar cookers we'll be plating like what to say, we'll be having a black plate at the exact focus. Okay, so what there will be like this plate also will be having a black color, so it absorbs all the heat which is coming there. So this plate will be having too much of heat. Okay, all those light will be concentrated here, so there will be too much of heat produced. With that we can actually cook the food, cook the food. Okay, so that is what about what the first thing. And then concave mirror converges the light rays falling to it into the point. That is exactly what it is, like what we are actually using here. All those rays which is coming parallel will be converging and which will be directly focused to this particular focus. Understood? Which is the principle of this thing. Okay, so here both assertion is actually here also assertion is true, reason is also true, and this is the right explanation. Assertion and reason is the right explanation. Okay, so option A is the right answer. Understood? Okay or not? Fine. Now we can go for the like what to say numerical based and diagram based question. Okay, listen. Okay, so Rohit want to have an erect image of an object using a converging mirror of focal length 40 centimeter. Listen, see what is this? This is converging mirror. Converging mirror means it is concave. Okay, it is concave, and then it's having focal length which is 40 centimeter. Okay, fine. He want to have an erect image. He want to have an erect image. What is erect image means? Listen people, erect image means like only in one situation I'll be getting erect image. Where is that? It is when an object is kept between F and P. Okay, it will be between F and P. So let it be like I'm drawing a concave mirror here. Okay, converging mirror means concave mirror. Okay, now let me draw a principal axis. Okay, listen, let it be this is the focus here. Okay, so here will be the C. Okay, I want to get an erect image. All the situation, let it be like at infinity, beyond C, then what to say at C, between C and F, at F, all those image will be giving you what? Real and inverted image. Real and inverted image. But what about this case? Here it is not like that. I want an erect image, so it is clearly no. What is it? The object should be kept here. I should be keeping the object here. So specify the range of the distance where the object can be placed in front of the mirror. Okay, I should be like telling where it should be the object kept. Okay, what is the focal length here? See, the focal length is straight away given. It is 40 centimeter. Okay, it is given 40 centimeter. So I should be keeping the object where? I should be keeping the object. I can keep this particular object. Okay, I can keep this object where? Anywhere between 40 centimeter and 0. Okay, so it is like from 40 to 0. Anywhere I can place all those what? Object where it is kept between F and P. Here it is P. So F and P will be giving you a virtual and erect image. I'll be going to the diagram after this. Okay, so what is it? Here the specify the range means the range is between what? 40 centimeter to 0 centimeter. All those what to say it shouldn't be equal to 40, it should be less than 40 to 0. Okay, so that is the range of the distance where the object can be placed. So next question, draw the what to say like or say we have to write the ray diagram. So draw the ray diagram to show image formation in this case. Draw the ray diagram. Okay, so let's draw it again. Okay, let's take it as like a perfect picture. Okay, we do have a concave mirror here. Okay, and then if you are drawing this what to say ray diagrams, always remember one thing, try to take the exact values. Okay, or else like an approximate values, or else you want to be getting a perfect image formation. Okay, now this is principal axis taken. I can extend it a little bit more and then take a focus here. Okay, and then here I'm taking C. I'm just taking an approximate distance here. Okay, and listen, see what is the C value? C will be how much? So R will be how much? See, F is equal to what? 40 centimeter. This is 40 centimeter. So obviously C will be equal to 80 centimeter. Okay, I'm not talking about it. Okay, now listen, I'm going to keep an object. Where I'm going to keep the object? I should be keeping the object between F and P. I'm keeping an object here between F and P. Anywhere you can keep between F and P. Then only I'll be getting a virtual and erect image. Okay, and listen. So in order to form an image, there should be two light rays which is going to meet together. So listen, I'm drawing one line. Okay, it will be like one beam is like drawn which is parallel to principal axis. And what happens to this thing? After reflection, it will be bouncing back through focus. It will be reflecting back through focus. Okay, fine. Now, in order to make an image, there should be two light rays which is going to meet together. Okay, so I have to draw one more. Okay, so where I can draw? I can draw it to the pole. So, okay, one beam of light which is going to the pole. Okay, after reflection, what it will be making here, the angle of incidence will be equal to angle of reflection in the pole. Okay, so what happens? It will be making an angle. Okay, so here they will be making an angle. Listen. Okay, they will be making an angle here. So what happens? Listen, see, this is going like this. See, these two beams are not going to meet together. They are not going to meet together because see, this is going in one direction, this is going in another direction. So they are not going to form any image. So what we have to do is like we have to extend the other line. Okay, the other side. What is it? So listen, I'm extending this beam of light. Okay, other line is also extended back. And later I have got an image which is here in this behind the mirror. What is it? I'm getting an image in this side, this side of the mirror, behind the mirror. I'm getting an erect and a virtual image. I'll be getting a erect and a virtual image which is behind the mirror, which will be behind the mirror. So this is the image formation of what? A object which is placed between F and P, between F and P. Understood? Okay, now state one of the use of the mirror based on the above kind of image formation. So what is the application of this? Concave mirror have different applications. Of that we have discussed a few things in the earlier. Okay, so now what is the application of this thing? Where I'm keeping the object very near to the mirror. People listen, see, when it comes to the dentist mirrors, see, they will be keeping their mirror very close to our teeth so that they will be getting an enlarged image. See, I'm getting an enlarged image here, right or not? So likewise, if I want to get an enlarged image, I have to keep the object very close to the mirror. So dentist mirror, shaving mirror, makeup mirror, all are the example of what? This kind of situation. Understood? Fine. Now let's go for the next question. Listen, so this is a numerical question. So an object of height 1.2 centimeter is placed before a concave mirror of focal length 20 centimeter. Let me tell you one thing before we do this question. Listen people, whenever you are doing a numerical question, always keep one thing in mind. Don't go for the first equation itself. Write one by one the things given in the question, or else you will be having what? A mistake which is going to happen. Okay, so listen, so I'm just reading all those statements one by one. So an object of height 1.2 centimeter is placed. So object it is. So what is it? Height. HO is given. HO is given as what is it? 1.2 centimeter. Okay, fine. Then it is placed before a concave mirror of a focal length 20 centimeter. Okay, fine. Focal length is given. What is it? 20 centimeters. See, this is a concave mirror. So focal length we can take it as negative because the image will be formed in the same side of the mirror itself. Okay, so here it will be negative itself. Okay, now then what is it? And then so that a real image is formed. See, it is like it is forming real image. So real image will be always forming in this side only. Okay, and then image is formed over at a distance of 60 centimeter from it. Okay, so image is formed over 60 centimeter from the mirror. So what is it given? V is equal to 60 centimeter. Here also the image is formed in the in front of the mirror. So here it will be again negative. Hope you remember I have told about this Cartesian sign convention before. So what is it here? Always understand one thing, always u is equal to what? Negative, because always I'm keeping in front of the mirror. Okay, so always u will be negative in whatever it is, like mirror, lens, whatever it is, like u will be always negative. But when it comes to v, it can be positive or negative where the image is formed. If the image is formed here, see here it is formed as what? Real and inverted image. So it will be like it will be forming here. Hope you know how is the image formation happening in the concave. Okay, so here it is forming this side itself, so it is again negative. This is also negative. If any kind of like image is formed in this side, it will be positive here. So what to say, focal length and then image distance has to be taken as negative. Okay, fine. Now listen, what has to be found? Find the position of the object and what will be the height of the image formed. So we have to find what is the position of the object. Position of the object means object distance has to be found. What you have to find? That is u is equal to how much. So these are the initial things what you have to write before you go for the what answer. So before like we complete this reading the question itself, you have to write all these things. HO 1.2, F is equal to 20, minus 20, V is equal to minus 60, all these things. Okay, and I prefer one thing, whenever you are doing a question, see, I prefer one thing, always what to say, you can draw a rough sketch in the side. Okay, you can draw a rough sketch in the side of it. Not equal values and all, like, but still it will give you a confirmation whether your answer is right or not. For example, here I'm having a concave mirror here. Okay, listen, and then what is the focal length given? Focal length given is 20 centimeter. Okay, and then obviously this C will be how much? C will be 40 centimeter. Okay, and I don't know where the object is kept. I don't know where the object is kept, but I know one thing, where the image is formed is at 60. So it will be formed somewhere here. It will be formed somewhere here. Okay, so it is 60 here, it is 60, understood? And where is this? This is F, this is C. So the image is formed beyond C. The image is formed beyond C. So tell me please, where we'll be getting an image beyond C? I have to keep my object between C and F. Only then only I'll be getting an image what? At what? Beyond C. Understood, people? So before we find the actual answer, I have a prediction where the image will be found between C and F. Understood or not? Also one thing, the answer what you are getting, should be a value which is less than 20 and 40. The answer what you are getting should be between 20 and 40. If it is not, your answer is what? Wrong. Understood? So you can, it will be always helpful if you draw a rough sketch. You don't have to take this all the values and all, but a rough sketch which will take very less time only. Okay, listen. Now we have to find what is u. What is the equation, people, here? See, we know the mirror equation has to be taken. So what is it? 1 by F is equal to 1 by V plus 1 by U. Okay. Then two equations what you have to study in this reflection part is, first one is 1 by F is equal to 1 by V plus 1 by U, and also one more thing, magnification, which is equal to HI by HO, which is equal to minus V by U. Always keep these two equations in mind. This is the only two equations which is to be studied in this reflection part. Okay, and if you study this thing, you can do majority of the questions in the what? Mirror side question. Okay, mirror reflection part question. Okay, so it is like these two equation has to be used for us anyway. Like I'll keep this the sides. Okay, so 1 by F is equal to 1 by V plus 1 by U. Okay, so listen, so we know 1 by F is equal to, how much? 1 by F is equal to 1 by V minus, plus 1 by U. Of that, I'm taking V to this side so that U will be there. So what is it? 1 by F minus 1 by V is equal to 1 by U. Okay, fine. What is 1 by F? 1 by F is 1 by minus 20 minus of 1 by minus 60. Isn't it? 1 by minus 20 minus 1 by minus 60. Okay, which is equal to 1 by U. And then how can you solve this? See, listen, here it is minus and minus, you can make it as plus. So it is 1 by minus 20 plus 1 by 60 here. Okay, because this minus and minus will become what? Positive. So here now we have to go for the LCM. So here we can take 60 as a common value. So what is it? 1 by 60. You can take it as 1 by 60 as the common value. So it will be what? You have to multiply with this value. See, this is 20 has to be multiplied into what to say? It should be multiplied into minus 3. It should be multiplied into minus 3, then only it will be becoming what? 60. So here it should be multiplied into minus 3 plus what? 1 plus 1 itself. So what will be the value here? It will be minus 2 divided by 60. 1 by u will be equal to minus 2 divided by 60. So listen, 1 by u is equal to 1 by 60 can be actually like we can cancel this. It will be 1 by 30. So what is it? 1 by u is equal to minus 1 by 30. So u is equal to minus 30 centimeter. Was our prediction right or not? U is equal to minus 30. Our prediction was right. Understood? Okay or not? Now we have to find what is the next one. What is it? What will be the height of the image formed? We have to find what is the height of the image formed. Okay. So for that I'll do it this side. Okay. Okay. Wait. So we need to find height. So how can I find height? Hi is equal to what? For that we can use the equation of magnification. Magnification is equal to minus v by u. Magnification is equal to minus v by u. And I'll predict one more thing. Listen, if I'm keeping an object between C and F, it should be a very enlarged image also. Okay, it should be greater than this value. Okay, let's see here what is given. So what is it? Minus into minus 60 by minus 30, isn't it? So magnification will get minus of, like these two values will cancel out. It will be 2. Okay, so answer is minus 2. Magnification is minus 2. We do have one more equation. Magnification is equal to hi by ho. So from that hi is equal, hi is to be found, it is mho, which is equal to minus 2 into ho is how much? It is given in the beginning itself. Ho is given as 1.2. 1.2. So it is minus 2 into 1.2. It is minus 2.4 what? Centimeter. Minus 2.4 centimeter. Listen all of you one thing. Listen. See here the magnification is equal to what? Minus 2. Magnification is equal to minus 2. See, magnification will give you some idea about what is the image formed. See, magnification is equal to 1. Magnification is equal to 1 gives it is of same size. Magnification is equal to 1 give you it is same size. If magnification is greater than 1, it means the image formed is enlarged. The image formed is enlarged. Okay, and then if the magnification formed is what? Less than 1, then it is diminished. The image formed is what? It is diminished. Okay, fine. And one more thing I'll tell you, always the magnification will be having either it will be positive or negative. So if the magnification, let it be magnification will be always equal to some value will be there, positive or negative, and then one value will be there. Okay, let it be like I'm having 1. Okay, and this positive will indicate what, you know, if the magnification value is positive, it indicates it is virtual and real. It indicates it is virtual and real. And if it is negative, it indicates what, you know, it is, sorry, it is not virtual, what to say, what is, sorry, it is not virtual, it is like virtual and what to say, erect. Okay, and then what to say, when it comes to minus, it will be what? It will be real and inverted. Real and inverted. Okay, sorry. Okay, so please understand what is it here. Positive will be indicating what? Positive will be indicating it is virtual and it is erect, and the negative will be indicating what? It is real and inverted. Okay, so here I am getting negative value. Here I'm getting a negative value, which means it clearly says it is real and inverted. Also, this is greater than 1, which means it is enlarged. Am I getting an enlarged value or not? Yes, it is. Understood or not? Okay, so this is the way of like finding the answers. Okay, you can expect these kind of questions for around 3 to 4 marks. Okay, now to the last question of today's discussion. Okay, so there is a student who wants to project the image of a candle flame on a screen of 80 on a screen which is at 80 centimeter in front of a mirror. Okay, so there is a student that is like there is a candle flame which has to be like projected onto a screen. Okay, and listen, see, it has to be projected onto a screen. Okay, so it has to be projected onto a screen of 80 centimeter. Understand one thing, people. If I want to get an image on a screen, then the image form should be what? It should be a real image. There should be a real image which is to be formed. Understood? So there is a real image which is forming here. Fine. So in front of a mirror, by keeping a candle flame at a distance of 20 centimeter. Okay. So listen here. See, I'm keeping an object which is at 20 centimeter. So u is equal to 20 centimeter, and then if I'm keeping this object at the 20 centimeter, I'll be getting an image at 80 centimeter. I'll be getting an image at 80 centimeter. Fine. So v is equal to 80 centimeter. And listen, people, which type of mirror should be used in this situation? Which type of mirror should the student use? One thing you have to understand. Listen, here there is a real image which is formed. Only a concave mirror can form a real image. It can be only formed with a concave mirror. So listen, so it is u is equal to 20 centimeter, which will be given with minus, and since it is a real image formed, it will be also what? Minus. So u is equal to minus 20, v is equal to minus 80. Fine. So first answer we have got. What is it? It's concave mirror. Okay. Next, find the magnification of the image formed. We need to find the magnification. So actually magnification we can actually find with the easy equation. Magnification is equal to minus v by u. Magnification is equal to minus v by u. So what is minus v by u means? Like it is minus 80 divided by minus 20. Altogether it is one more minus is there, so it will be, this can be cancelled, so it will be 4. This will be 4, so the answer will be minus 4 will be the answer. Okay, magnification won't be having any units, so we got the magnification value which is equal to minus 4. Now what is to be found next? Okay, find the distance between the object and its image. We have to find the distance between the object and image and its focal length. So for that, I'm just drawing a simple picture of this concave mirror. Okay, so this is the concave mirror, and then it will be, this is the focus here, this is the C, center of curvature here. Okay, and listen, I'm going to keep object where the object is kept. Object is kept at minus 20 centimeter, and what is the focal length? I don't know. Okay, so let me, I don't know what is F and C, all those things I have to find. Okay, so listen, see, I have to find the distance between the object and its image. See, whatever it is, like there is an object which is kept somewhere. Okay, let it be this, here is the object kept, and I'm getting an image, let it be somewhere. Okay, I don't know where it is. See, here this distance is how much? The distance between the mirror and the object distance is 20. Always it is taken from the mirror, I have told. Okay, and then the next distance is from what? From, it is again from the mirror. It is again from the mirror, it is 80. So what is it? This is 80. Okay or not? So it will be 80. It is 80 centimeter. So what is the distance between object and image? The distance between object and image will be how much? It will be 60 centimeter. It will be 60 centimeter. Understood? Okay, so we have got the answer for this. This is equal to, not this, this is equal to, this is equal to minus 4. About this thing, it is like distance between them is 60 centimeter. Now let's go for the focal length. We have to go for the focal length. We have to go for the focal length. So let's see how much it is. Okay, for finding the focal length, what do you have to do? Finding the focal length, we have to use the equation 1 by f is equal to 1 by v plus 1 by u. 1 by f is equal to 1 by v plus 1 by u. So what is 1 by v? It is 1 by minus 80 plus 1 by minus 20. Okay, understood? Fine. So we have to go for the LCM. So I'll take it as 80 here, minus 80. I'm taking it as minus 80. So what do you have to do? To make it to 80, you have to multiply this into 4. This also should be multiplied by, this should be multiplied into 4. This should be multiplied into 4. So minus 20 into 4 and 1 into 4. Okay, so what it will be? So this is like multiplied into 1. This is multiplied into 1. So it will be 1 plus what? 4 into 1 will be 4 itself. So altogether the answer will be what? 5 by minus 80. 5 by minus 80 will be giving you 1 by f. So what will be the f, people? It will be 1 by f is equal to 5 by 80. So f will be equal to how much? Just the reciprocal. F will be equal to minus 80 divided by 5, which is equal to how much? 80 divided by 5. I can take 16. 1 6. Okay, so 16 is a multiple. 16 into 5 is how much? Minus 80. So what is it? Minus 16. So when it comes to the divisions of 5, you can use the trick. What is it? See, this is a minus 80 divided by 5, right? So if any number is divided by 5, you can actually what? Make this number, the number which is to be divided should be made into its double. So what is the double of what? 80. It will be 160, and then cancel that 0 will give you what? Cancel that 0 will be giving you the answer for it. So you can also take it as a what? Tip. Okay, so what is it? Any number divided by 5, we will be getting like, what you can do is like multiply that number into 2. Okay, and then divide it by 10. So you can get the answer. It is okay. Okay, so what we have got the focal length here? It is minus 16 centimeter. What is it? Minus 16 centimeter is the focal length of this. Okay, understood? So here we have got the magnification, we have got the distance between the object and the object distance, and this image distance we have found, and then we have also found the focal length. Okay, so please understand, when it comes to the numericals, please start with writing all those things. Okay, write all the steps one by step, then only you can find the answer. Okay, so this is all about the chapter light reflection part. Later I'll be coming with the refraction part soon. Until then, bye. Thank you. Bye. Hello everyone, welcome back to Excel Education Center. It's me, Nabeel. So today I'm going to discuss some of the important concepts and the important questions of the chapter light. So this chapter, I'm actually dividing this chapter into 2 parts. So today we'll be discussing mainly on the part of this chapter which is called reflection. Okay.